Hey class, so here's a homework video for problem 69 from the homework. A few people have had questions on this one. So, in this problem we're asked to try to determine what the tension is in this string here, right? So we're trying to determine the tension in that rope, and we're told about the forces Fa here and Fb that's shown here acting on this other block. And we're told that they both have I components only and no j components. So what that means is that Fa is only in the x direction. So what that means is that Fa, which might be equal to, let's say, 12 newtons in the I direction, what that tells us is that you have an Fa in the x direction that's equal to 12 newtons. Oops, getting excited. That's equal to 12 newtons, and that the y component of Fa is just equal to 0. And similarly for the b one as well. So what you do then to try to get started on this is, as we always do, start with free body diagrams. So if we start with block A, look at its free body diagram, what forces do we have acting on it? Well, we have that tension force pulling on it, so we can go ahead and draw that on here. We also have that force Fa, which is only in the x direction. And then you also have the weight force and the normal force. But those we're actually not going to have to worry about because we're only interested in what's going on in the x direction in this problem. So similarly, we need to draw a free body diagram for block B. So to be accurate, we should include its weight. Weight B. This is weight A. We should keep our subscripts clear, and so there's some second normal force here. And then here the tension force now is acting in the negative x direction, and it too has its force Fb acting on it in the positive direction. Okay, so we want to try to determine what that tension is. Maybe I should label it here. Okay, but in order to do so, we first need to figure out, is there even going to be a tension? There could be a case if Fa is strong enough, quite a bit stronger than Fb, for example, you could have a case where the tension is actually 0. So you need to consider that case first. So is the tension equal to 0? Alright, so what would happen if the tension was equal to 0? Well, what that would mean is if the tension is 0, that would result in a situation where your block A, so let's say this guy is accelerating this way, right? Block B should also accelerate the same way. So if your acceleration of A is larger than that of B, it will be catching up to block B, which means there would be slack in that rope. So that would be a situation where your acceleration of block A is larger than the acceleration of block B. Okay? So the tension being 0 would imply that about the accelerations. So what you need to do is check to see if the tension is 0. Alright? So to do that, you'd have to start with block A and say, okay, the sum of my forces for block A would be equal to MA. And so if the tension is 0, the only force in the x direction would be the tension. So all you'd have is that the tension is 0, so it's not there. So the only force left is Fa. So Fa would be equal to the mass of A multiplied by the acceleration of A. So from that you could find that the acceleration of A would be equal to that force A divided by the mass of A. Similarly, you can look at block B and you'd get the same thing, that the acceleration of B is equal to force B divided by the mass of B. So that's only if the tension is 0. So you would want to calculate, everyone should calculate and check to see, is this acceleration A larger than B? If that's the case, then your tension would just be equal to 0. Alright? But I'm guessing, and I pretty much know that for all of you guys, I'm guessing your acceleration of B is going to turn out to be larger than your acceleration of A, which means tension does not equal 0. Okay? So, good. Phew, I'm glad we settled that. So now what you're going to need to do then is you're going to need to look at your two free body diagrams that you drew here and try to do sum of the forces for each one and use that to solve for your tension, and then you can solve for the tension and the acceleration if you want, but the tension is all that we're looking for, right? So if you start with block A, sum of your forces for block A will be equal to m times acceleration. Now that we have a tension, we know that they will be accelerating together. So you're going to have T plus Fa equals mass times acceleration for that block. And similarly, you can do block B. Sum of the forces in the x direction for block B is equal to mass of block B times its acceleration. And so now you're going to have Fb minus the tension equals mass of B times A. So now you have two equations with two unknowns. Circle them up. They're practically box worthy, but I'm going to circle them since they're not the answer. Two equations with the same two unknowns, so you should be able to solve for that tension force. Good luck. Let me know if you have additional questions, and I hope this is helpful.